All right, so we are moving through chapter 2, and 232, we kind of took on the hardest part of it, which was the sigma notation connecting the area and the curve. Now we're going to move forward to taking that area, moving it, and also looking at negative area. So what you're going to see in this video are the flipbook notes from sections 233 and 234. We'll start at the top of 233 by talking about negative area. Oops. All right, and negative area is actually a relatively simple concept. I'll illustrate it in written form and then also in graphical form. So the area under the curve will be either one of two things here. It will be positive if the area is above the x-axis, and it will be negative if it is below the x-axis. Graphically, a way to look at this, if we were to sketch this out, we're going to introduce quadrant 4 now. So we have positive and negative values. If I was to draw this, all the area above the x-axis, but under the curve, kind of trapped in that area, is positive, and everything below the x-axis will be negative. So now we can talk about negative area, and we could also talk about zero area if they cancel each other out. It all kind of depends on the context of the problem and what we're dealing with. I know with the McMega problem we were dealing with dollars in terms of profit and loss. So the negative values represented loss, where the positive values represented profit during a given period. Okay. The next concept, which we explored in class today, was called shifting area, which is connecting what we did in chapter 1 with area under the curve. So shifting area, I'm going to write out some math notation and then we'll translate it. Given the area function f on the interval a to b for I'll go ahead and break this down for you. So given what this is going to mean, given the area on function f with a certain domain, I'll take a new function g, and I'll translate my original by applying one of two things to it, either a horizontal or a vertical shift. So this is kind of similar to the problem we were doing earlier in class, where we had f, which was, let's say, f equals 2 to the x, and then we'll say function g is 2 to the x plus 1. All it's dealing with is a transformation, which is translating my parent function. So then the question becomes, what do h and k do to change my area? So if we look at each part, the h value, there is no change as long as the domain shifts also. So we got to move the interval with it. And then the k value, we will add or we will subtract a rectangle. And we'll explore that in an example. So h, there's no shift in area because we're not moving it up or down. But k, if we do move something up or down, we will get a change in area. I'm going to look at an example for this. So this will go on the bottom of your flip book. And we'll unpack this. So the example is, suppose the area shown is 23.1 units squared. Alright, I'm going to graph this for you so you can see it. Okay, interesting looking graph. We're going to restrict its domain on the interval 1 to 4. We're going to be looking at all the area under this curve. And we're going to call this function f of x. And we are going to suppose that this area is 23.1 units squared. Now we're going to do a little with this. So part A, given the area of function f on the interval 1 is less than x less than 4 is equal to 23.1, find the area of G if G of x equals f of x plus 2. And we'll need to write our new domain. So in thinking about this, we know that I have a horizontal shift of 2, and since it's horizontal, there's no change in area under the curve. So my new area is 23.1 units squared. And my new domain will be, if we're shifting 2 units to the left, we're going 2 and 2. My new domain will be -1 is less than x, which is less than or equal to 2. Or you could say -1, comma 2. An interval notation. So that's for part A. Part B, same thing. Given the same area, assume this is the same, find A of, we'll call h now, if h of x equals f of x plus 1 plus 4. Identify your shifts. We're going left 1 and up 4. So there's no change with the horizontal, but there is a change with the vertical. We're going to be adding a rectangle. The rectangle has a height of 4. And since the base, go ahead and erase this. Since the base is 1 to 4, there's a difference of 3. Our base is 3, we'll be adding 12. So our total area will be 23.1 plus 12, which equals 35.1 units squared. And our domain, since we're going 1 to the left, will be, I'll show you an interval notation, 0, comma 3. And that's for part B. So again, the horizontal shift has no effect on the area, only the vertical shift. Remember to shift the domain with it. The other part of this that's going to seem a little random is multiplying rational expressions. So this will go to the right of what you had on the bottom. And we did this with adding earlier, but it's good to revisit it. And multiplying is actually easier than adding because you don't need that common denominator. So we'll look at this. Multiplying rational expressions, and we'll look at one example. And this should be a little bit of review from Algebra 2. So simplify. X squared minus 4 over x squared plus 4x plus 4 times x squared minus x minus 6 divided by x squared minus 9. Alright, back to Algebra 2. This is actually really fun. This is all factoring. So you're going to think factor. So go ahead and factor the top and the bottom. difference of squares on the top. X minus 2, x plus 2. On the bottom, some of you, it might help if you're using the x box, or the x. 4 up top, 4 on the bottom. What two numbers multiply to make that work? 2 and 2. They add together also, so x plus 2, x plus 2. We can use the x over here too. Negative 6, negative 1. So I know that negative 3 and 2 multiply to make negative 6 and add to make negative 1. So my answers here is x minus 3, x plus 2, and then another difference of squares, x minus 3 times x plus 3. Alright, now it's fun. We get to simplify, so look for your like terms. Minus 3 done, plus 2, and plus 2. So we are left with, simplified form of this will be x plus 2 over x plus 3. However, x cannot equal negative 3 because it will be undefined. Oh, with 0 in the denominator. You cannot put negative 3 in here because it will make, it will make this whole expression equal to 1 over 0, and that's undefined. Doesn't work. We'll talk more about what this is going to look like graphically, but for now, the algebra is what's important.